Today we have a AMC 10B problem. So this was number 23 on the test. So the number n is given as the 79-digit number that is formed by writing integer 1 through 44 in this given order, one after the other. So what is the remainder when n divided by 45? So like we are trying to find the remainder. You know, when we talk about the remainders, like there are usually comes into mind like the remainder theorem, which is about the polynomial, but also modular arithmetic as well. So, but in this case, there is no polynomial, so which we will use the mod. So, but at the same time, we are going to divide by 45. So, which is why it's kind of harder to deal with. So, which is why we will find two numbers that is relatively prime. So their product is going to be 45. So I can take 5 and 9. Because when you have two numbers that is relative prime, then if the number, which is n, is divisible by 5 and 9, then number n should be divisible by the LCM of 5 and 9, which is 45 as well. So that is what we are going to use. And like when we look at the number n, it's obvious that last digit is 4. So which is why that number, the n, is gonna give us a remainder of 4 if I divide by 10 by 5, which is why I'm gonna just write this guy as n is congruent to 5, 4, right? Mod 5. So this is just the congruence statements. So if you don't know about this, you can take a look at a bit background on this, but that is just the basics. And the same idea, we just want to know the remainder of this number when we divide by 9. But the divisibility rule by 9, you just add the digit. So since we have like 79 digit, which we need to make sure we are kind of satisfying this guy. And we want to add these numbers. Like one way to add these, like you can probably kind of find different ways, but at least the way that I think is for this number is I can see that like when you kind of like split the numbers 1 through 9, even maybe 0 through 9, and then 10 through like 19, and 20 through like 29, and 30 through 39. Each one of those group of 10 until they 39. So we have 1, 2, 3, 4, 5, all the way to the 9 as the unit digit. So meaning that we have like 1, 2, or 3, all the way to the 9. We have 0, but it doesn't add up anything. So let's see it right anyway. So we have these numbers on the unit digit 4 times. So when we start with like the first digit, like will be just these guys. But when we have the after 10, including 10, so we have 0, 1, like this 0, this 1, this 2. When you have 19, so 9 of that, 19. So when you add the unit digit, so we have this like group of 10 digit will repeating 4 times, right? So that is just this. Plus, we have 40, right? So at the end, which is gonna be 4 plus 0, and then 41, 42, 43, and 44. So we have like 5 of these, like 4, plus the unit digit of 0 through 4. So I can just say 0, 1, 2, 3, and 4. So these are the unit digit after the 40s, like, 40, 41, so and stuff like that. And but we also have the, I took the unit digit of those numbers 1 through like 39 on this guy. And at the same time, we have like 10s and 20s and 30s. Those like the 10s digit of 1s and 2s and 3s will be counted like for every integer on those 20s and 10s. Just imagine like, just think about this with like 10, like 11, 12, all the way to the 19. So this 10th digit of 1 will repeat like 10 times, including 10. So 10 to 19. So we have 10 of these. And the same way, like 20, 21, all the way to the 29. So these twos will repeat 10 times as well, same as 30s. So which will be add up to like 10 of 1s, 10 of twos and 10 of threes, right? And then these are gonna be my numbers. And if you wanna kind of quick check, so we have like 1, 2, 3, right? Three digit, like think about the number of digit. We have 10 of each, which is gonna be 30 of these. And then for the second one, we have 0 through 9, which is 10 digit. And then if you multiply this by that, so you get 40 digit. So which looks like 70 already. And then 4, 5 was the 5 was the number of digits. So we have 5 of these 4. So we have 5 more digit. That is all 4. And then right here, 1, 2, 3, 4, 5 more. Actually, we took this extra 0 because at the beginning I said like that we can add 0 to make that group of tens, but we don't have the S0 actually. So maybe instead of having this 5, so I can say this is 4. So when you add them, so you see that 79. So which is gonna be kind of another easy way to check it. So anyway, so that means if I add these guys and divide by 9, I will get the remainder. So then this is gonna be like 10. This is gonna be 3 times 4 over 2, which is 6 by just the cows. And then 1 through 9 is, let me write that, 9 times 10 over 2, so 9 times 5. And 4, 5 is 20. And then 1 through 4 is 4 times 5 over 2, which is 10. You can just add them as well. But we don't want to add and multiply these things because we are going to take the mod 9. So I can say 10 is congruent to 1 in mod 9. So that will be just 6. And then that will be a multiple of 9, which is going to give us 0. And then 18 plus 2 is 20, which is going to be 2 for mod 9. And then it's going to be 1. So that is mod 9. So when you add this 6, 2, and 1, which is going to be 9. So 9 is congruent to 0. So 0 mod 9. So meaning that that's divisible by 9. So meaning that our n is congruent to 0 mod 9. So our goal is to find a number n that is gonna be leaving us a remainder of 4 when divided by 5, and the same n should be divisible by 9. So you can kind of go ahead and like add 4 to a multiple of 5 until you hit a number that is multiple of 9, which is easier to, I guess, kind of find that. But what I will do, I'm gonna use the kind of a congruency system of congruency to solve this one, because we know that since 5 and 9 is relative prime, so there should be a unique solution when we take mod 45. So by the Chinese remainder theorem. So Chinese remainder theorem is just telling us there is gonna be a solution, but it doesn't really tell us how to do that. There is even like a longer way to find those solutions, but it's kind of harder to use it, so we just don't use anyway. So what we are gonna do, I'm gonna write this guy as the equation. So that means 4 more than a multiple of 5, so which can be written like this. And the same thing can be written as a multiple of 9. So I'm gonna say, let's say 9 times b. So we are gonna find the n, but we can take the mod of something to remove at this a or b. So I'll take mod 5 to make that a is gone, because if I take mod 5, this will be congruent to 0. So that should be 4 is congruent to, if I take mod 5, so that will be 4b, and then mod 5. So then there are like some ways to solve this congruency for b, so other than just plugging, but I'm going to plug now to get that b. So if I choose like b like 1, that will be 4 times 1, which is like 4. So that will be immediately answer. So the answer would be b is congruent to 1 mod 5. So which is the same as saying that b is 1 more than a multiple of 5. I will say k is some integer. And to get b, to get n, I'm gonna plug this back to the original equation because we are interested in n. So that will be equal to 9 times b, which is 1 plus 5k, right? And that is equal to 9 times 1, 9. 9, 5 is 45, and that is 45k. So then n can be written as 9 more than a multiple of 45, same as n is congruent to 9 mod 45. And that is our our answer. So again, this is not too challenging question, but if you are kind of confused at some point of this, so it might be a good idea to review some basic of the modular congruencies. So that was the thing that I just used in this list. Anyway, so I'll see you in the next video.